The search for life beyond Earth. Webb's ocean world discovery. The James Webb Space Telescope now stands as the most advanced and powerful observatory ever built for space science. It represents a major leap forward in our efforts to understand the cosmos, designed specifically to explore the deepest and most complex mysteries of our universe. Its mission is vast and awe-inspiring. It seeks to uncover secrets hidden within our own solar system, investigate distant planets orbiting stars far beyond our reach, and examine the intricate structure of the universe itself, all while helping us understand the role of Earth and humanity in the grand cosmic narrative. In one of its most exciting initiatives, scientists recently directed Webb's extraordinary lens toward a distant star. This star lies an astonishing 120 light-years away from Earth, in the direction of the constellation Leo. Orbiting this faint red star is a planet that has caught the attention of astronomers across the globe, K218b. To everyone's surprise, the James Webb Telescope revealed compelling evidence of carbon-based molecules, specifically methane and carbon dioxide, within the atmosphere of this intriguing exoplanet. These carbon molecules are considered key indicators when searching for potential signs of life beyond Earth. Their presence has caused a wave of excitement and curiosity in the scientific community. But how did such a discovery become possible, and what does it mean for us? This revelation offers an unprecedented glimpse into a world that could not be more different from anything in our solar system. K218b is not a gas giant like Jupiter or a rocky world like Earth. Instead, it falls into a unique category of exoplanets, those that lie somewhere between the size of Earth and Neptune. This type of world, often referred to as a sub-Neptune, is surprisingly absent from our solar system, making K218b a particularly rare and valuable object of study. Webb's findings suggest that this planet may possess a hydrogen-rich atmosphere, possibly resting above a deep, planet-wide ocean. If this is true, then K218b could very well be what scientists refer to as a Hycean world, a potentially habitable planet with conditions suitable for liquid water beneath a hydrogen envelope. NASA's Hubble Space Telescope had previously studied this exoplanet, and it was the first to hint at the presence of water vapor. But it is the Webb telescope that has now provided an extraordinary level of detail, revealing that this alien world might not only contain water, but also carbon-based molecules, which are essential building blocks of life as we know it. Even more intriguing, some earlier observations pointed toward the possible presence of a chemical called dimethyl sulfide, a molecule that, on Earth, is produced only by biological life, specifically by marine phytoplankton. If confirmed, this would mark one of the most significant biosignature detections ever made. However, scientists urge caution. The signal for dimethyl sulfide is not yet robust, and further analysis is required to confirm its presence. Follow-up observations using Webb's mid-infrared instrument, MIRI, are already being planned. These future observations will allow astronomers to better understand the planet's atmosphere, temperature, and climate conditions, and most importantly, whether it could realistically support life. Although K218b exists within the habitable zone of its host star, where temperatures are just right for liquid water to exist, its size also raises questions. With a radius about 2.6 times that of Earth, the planet is likely to have a thick layer of high-pressure ice beneath its ocean. It may also have a thinner, lighter hydrogen-rich atmosphere on top. This configuration could potentially limit its ability to host life as we understand it. Even if there is water, the immense pressures and lack of landmasses could make the environment very different from Earth's oceans. Still, the discovery marks a monumental step forward. Scientists have now obtained the most detailed spectrum ever recorded of a sub-Neptune type exoplanet in the habitable zone. This was made possible by observing starlight as it passed through the exoplanet's atmosphere during transits when the planet crosses in front of its host star from our point of view. During these events, a small amount of starlight filters through the planet's atmosphere. That filtered light carries chemical signatures, clues about the gases and molecules present around the planet. These signatures are now being decoded by Webb, ushering in a new era of planetary science. Uncovering cosmic origins, Webb's glimpse into ancient galaxies, while the discovery of potential life-sustaining planets like K218b is thrilling. The James Webb Space Telescope isn't just focused on nearby exoplanets. Its powerful instruments are also peering billions of years into the past, revealing the chemistry of galaxies that formed shortly after the Big Bang. One of Webb's most astonishing discoveries involves the detection of complex organic molecules in a galaxy located at an incredible distance from Earth. These molecules, known as polycyclic aromatic hydrocarbons or PAHs, are the same kinds of chemicals found in smoke, soot, and industrial pollution here on Earth. But unlike Earth's pollution, these molecules were discovered in a galaxy that formed when the universe was just a child, barely 1.5 billion years after the Big Bang. At that time, the cosmos was only about 10% of its current age. This means Webb has helped detect the earliest known example of complex carbon chemistry in the entire universe. What makes this so important is the size and structure of these molecules. They're not simple gases like water or carbon dioxide. Instead, they are large, complex molecular structures made up of dozens or even hundreds of atoms. That such complexity could emerge so early in the life of the universe is simply mind-blowing. These organic molecules were found in a galaxy known as SPTO 41847, which, despite being ancient, already has a mass and structure similar to our own Milky Way. The stars in this galaxy are already producing carbon and oxygen in amounts comparable to our Sun, even though it is only a fraction of our galaxy's age. This rapid chemical evolution defies many expectations from our current cosmological models. How could such intricate molecules form in such a short time? What processes enabled galaxies to mature so quickly after the Big Bang? Webb's unmatched resolution and infrared sensitivity have allowed scientists to do what was previously impossible. They can now pinpoint the exact regions within galaxies where these molecules are forming. Prior telescopes could only detect the molecules in a general sense, now we can map them. Even more puzzling is the fact that these molecules are not evenly spread out within the galaxy. Some regions have high concentrations, while others are nearly devoid of them. This uneven distribution raises new questions about the early environments in which stars and planets formed. As our knowledge expands, so does our humility. We now understand that the universe was far more chemically complex in its infancy than anyone had imagined. Webb is rewriting our understanding of cosmic history, one molecule, one galaxy, one discovery at a time. The telescope's long-term mission includes studying thousands more galaxies, each potentially containing unique elements of the universe's early life story. So what does all of this mean for humanity? It means that the elements necessary for life may have existed much earlier than expected. It suggests that the building blocks of biology may be common in the cosmos, and not rare or isolated to our solar neighborhood. Each discovery adds a new puzzle piece to the cosmic picture, a picture of where we came from, and perhaps, where we're headed. The James Webb Space Telescope is much more than a marvel of engineering. It's a cosmic storyteller, unveiling tales from the birth of time itself and illuminating the path toward discovering our place in the vast universe. If you've been inspired by this journey through space and time, be sure to like this video, leave a comment below with your thoughts. Don't forget to subscribe and turn on the notification bell for more incredible updates from